Hey everybody. So far, we've been able to define a syntax for arithmetic and Boolean expressions. What do they mean? So implicitly, when we defined these expressions, look at them up on the side over here. I particularly like to program this way. Definitions one side, code I'm going to work on the other. When we define these, I gave the intuition saying like, oh, this represents a number, this represents the sum of two numbers, this is, or the sum of two expressions. This is A1 minus A2, this is A1 times A2. To make that sort of real, we have to define a semantics. Here, semantic just meaning having to do with meaning. So we'll define an evaluator, an interpreter, a function that takes an arithmetic expression, and returns a natural number. Right? It's going to run it. This is code that runs the abstract representation of our program. So let's look at how it works. I think it's really incredible to me that it's nothing special. It's just another program. You're just walking over more syntax. So, we look at the expression that we have, and then we say, what should we do with it? What natural number do we get out? Well, if our expression itself was a number, then that's easy. Just return the number. No big deal. If it was the sum of two numbers, then compute the sum of the recursive calls of the two things. Now, okay, this could maybe be written this way profitably, though the parentheses sort of set it out nicely. Kind of either way. To do the subtraction, to compute the program represented by this, you just find out what A1 means, find out what A2 means, and then subtract the second from the first. And then similarly for multiplication. Let's test it out. So if I evaluate 2 plus 2, what do I get out? All right, kindergartners and first graders everywhere are just wildly jealous. How do we do it? So, more seriously, this is to me actually really cool, right? We defined in 5 lines a simple notion of arithmetic. In 6 more lines, we said, hey, or 7, this is what we think this all should mean. Right? This is how we interpret it. And then, boom, we've got a way to think about and interpret arithmetic expressions. Okay, to check our understanding, now this is really just running a function like any other. I actually want to urge you to not think ahead when we evaluate these things. It's so tempting to look at this and be like, oh, I know what this will do. It's minus, I got it. I know what happens. The truth of what happens, the actual truth of what these expressions mean, is in this case, this aeval function. Right? That's the source of meaning. So you have to just follow it closely. Treat it like it's abstract, like it doesn't have anything to do with the numbers that you've been taught to work with so effectively. Okay, what does the following expression evaluate to? Aeval, and then here's this expression. Pause the video. So there's 2 ways to solve this. There's the honest way, and there's the way I just told you not to do. So the honest way would be to say, well, let's plug it in, right? This is going to be equal to aeval, this will be equal to aeval anum3 plus aeval, and then this guy. Okay, well, that's equal to 3 plus aeval anum4 minus aeval anum1. Just a paren over here. Okay, that's equal to 3 plus 4 minus 1. That's equal to 3 plus 3. That's equal to 6. That's one way to do it. The other way to do it, and I think this is a little bit cheaty, is to say, well, look, oh, this is 3 plus 4 minus 1. Right? That just translated to a string, and now I'm just going to do math. Right? 3 plus 3, 6. Like, okay. This isn't how the computer did it. This is how the computer did it. It's really important that you be able to do this bottom version of it too. When you're reading code, and it's totally fine to think of it this way, though occasionally, if you had a bug, right? What if we had written plus there? This way would have totally thrown you off. Whereas this way would have been like, oh, wait a minute. That's not what it says. The code says something different. So it's really important that you sort of actually follow what the code has written. You know, there are countless times I have found a bug in my code by just like going through slowly and stepping it in my head and looking at the code I've written down there, and eventually realize like, oh, that's just the wrong symbol. It's supposed to mean this thing, but it actually means that one. Like that's what I wrote down. That's not right. Let me fix it. So you have to keep yourself honest. Okay, so we can double check ourselves. Always a good idea. Brilliant. Okay, so then you have a task. Define a similar thing for booleans. So we have these boolean expressions over here. Define a function beval that takes a boolean expression and returns a bool. Now you'll notice boolean expressions, these two versions, have arithmetic expressions in them. So you'll have to call aeval from your beval function. So beq should really check equality. At what type? You'll need to figure that out. And ble should check less than or equal to. What type? What type do we have a less than or equal to? Think about that too. Okay, you should be able to use this as a general pattern, right? This is just, you're sort of like walking over, it's a traversal of the abstract syntax tree. So you should be able to do something similar for bx. Hopefully pretty analogous. All right, that's the first bit. In the next video, we'll be talking about doing things other than evaluating abstract syntax trees. So there's more than just running programs. There's other stuff we can do too. All right, I look forward to showing you.